here's Unity. I'm just going to create a new script here. I'll just create, coroutine test. I'll just call this coroutine test, just sort of as an initial thing. And let me double click it to open up Visual Studio, to open up my script in my IDE. I'm using Visual Studio. I'm on a Mac, incidentally, in case you can't tell. Everything I'm doing, of course, is, I shouldn't say of course, but everything I'm doing works just fine on Windows as well. And of course, then, if you were on Windows, you wouldn't be using Visual Studio for Mac. You'd be using, Visual Studio on Windows or Visual Studio Code or something like that. But anyway, now, in order to use the whole coroutine thing I was talking about, so it's based on something called an interface called enumerator. So I'm going to make a new private function, because I don't need to call this particular function from outside the class. Enumerator, and I'll call this, my coroutine. Great. And all right. The reason it's showing, the little squiggly red lines for an error is because coroutines require, they have to yield at some point. And so since I haven't written a yield line yet, the IDE is telling me like, oh, there's an error in this function. But yield is the real magic with a coroutine. That's basically the yield command. The yield keyword tells Unity when it's running, like, this is where to pause the function and then, pick up again, next frame. So, all right, oops, I misspelled that, but anyway, yield, return, I don't know, let's pause this one for, wait for seconds. We'll just wait for like a half second or something. So, incidentally, again, if you're new to Unity, then just note that I had the little F there because it's just a C# thing. It's sort of in Unity, most of the Unity API, all of it, I believe, but I'll hedge for now and just go with most. But most of the commands in Unity's API actually need float values, but if you just do a decimal place, by default, C# will actually create a, forget which value, I think a double. Anyway, it won't be a float value though, so that's why I got to append a little F there to say like, this is a float. So anyway, so that's all I'm doing there. And one thing you can do, although once we get around to the web request, this isn't going to be necessary, but one thing you could do is, you could, I don't know, var I equals h I. So in other words, like, I'm going to loop 4 times. You can actually put the yield in a loop and thus have the program like pause at inside of a loop and like debug.log. So this will just display some sort of console message. So iteration. All right, let's try that. Oh, and then of course I need to actually call it. So that's where another command, start coroutine, comes in. Now, my coroutine. Now, start coroutine, just FYI, that's actually a method of mono behavior. So this is a C# script. Or I'm sorry, I take it back. This is a Unity specific class, mono behavior. So anyway, and then once I use start coroutine, I throw in my method call. Note, by the way, this is this isn't just the name of the method. I've actually got the parentheses in there to call it. That's just part of the syntax for how start coroutine works. So anyway, I'm going to put that on the camera now. Now, if we watch down here in the console view, you'll see, the 4 iterations happening over time. Great. So that's how coroutines work. Now, though, I want to show a code itself. I'm going to okay, sure. Web request test. Why not? I'll throw that on the main camera as well. So at this point, what I can do, I'll just turn off the coroutine test because just turn that one off. No longer care about the coroutine test, but let's look at the web request test. So now what I'm going to do is I'm going to write some code that actually makes a web request, download some data, and you can see how that works. Now, incidentally, this of course implies that I have some data to download. So this is where there's a website called Open Weather Map, which I'm going to be getting weather data from. Incidentally, there's this website, Programmable Web, which just lists all kinds of APIs that you could connect to, but I'm going to be connecting to Open Weather Map. Now, as the way Open Weather Map works here, let me just actually just bring up Chrome as a matter of fact, just to find it. Open Weather Map. There we go. All right. So you go to this website, and you could, sign up for. They have paid accounts, of course. Like if you're going to be hitting their API a lot to gather lots of weather data. However, just for testing purposes, they do offer free, account access, free level of account access. So that's what we're using. I ahead of time created just sort of like a little testing account, a little throwaway where just so that I can use it for the stream. Oh, there we go. Test API keys. So when you have an account there, you're going to be given what's called an API key. That's how Open Weather Map, when you're making requests, you have to provide them with this API key, and that's how they're tracking, how much data you're using, that kind of thing. You can see, though, that in their API documentation, here's what the API call looks like. So we're just going to copy that, and over here, we're just going to say string URL. Now, obviously, I gotta change API key there to value of my API key. And then meanwhile, I had to put in a city. In my case, because I live near Chicago, I just I put in Chicago. It's sort of this test. So all right, let me just copy the API key, and there we go. All right, great. Now then, here I need to numerator. Let me see how. Oh, actually, wait. That's right. It's a separate namespace. I forgot about that. So up here, I'm just going to Unity Engine networking. The main Unity Engine namespace that gives you access to the majority of Unity's API. But in our case, there are a few additional namespaces some parts of the API exist under, and web requests are one of them. So here we need to have this unityengine.networking namespace. So anyway, now that I've done that, I can do there we go. And I'm going to do get URL. All right. Now, if I yield on the request send. So there's actually a just request.send method, but you'll notice it's marked as deprecated. So we're not going to use that one. So we use the request.send web request. And now in this case, then debug.log request download handler.txt. Oh, interesting. The whole concept of download handlers are kind of a weird thing. Basically, because your web requests can return different kinds of data, not necessarily. Usually, when we're making our web requests, we're going to be getting text. That's the main thing we're going to be doing. But sometimes you make requests to get images. That's a separate download handler. It's handling downloaded image data. There's also this Unity specific thing referred to as asset bundles, where you can have all of your assets in Unity packaged together into a bundle and download that. That would also have a separate download handler. It's just to handle asset bundles. So anyway, that's what's going on here. And finally, I'm going to do start coroutine again and call API. And let's check it out. All right, so you can see the request was made. You can see a whole bunch of data got returned by making that API call, by making that web request. So at this point, you'll notice the formatting of the data is JSON. If you're not already familiar with what JSON is, in short, it's just a way for data to be formatted so that programmatically you can make sense of the data. It's structured, and you can see how there's a structure to it where it's sort of like the name coordinate, contains within brackets like some other data and that kind of thing. There are multiple ways of formatting data, common ways of formatting data. XML is one of the common ways, and JSON is a very common way, especially these days. Now, C# can handle XML just out of the box. JSON, to parse that data, you actually need to have some sort of external library of JSON functionality. Unity itself does come with a JSON parser. However, Unity's included JSON parser, it's called JSON utility. I'm not a huge fan of, mostly because it's less flexible than other options. The option I tend to prefer is what's called JSON.net. That's a pretty common package that C# developers will be familiar with. In order to use it within Unity, however, the sort of like the stock JSON.net, it's made by this, Newton Soft. But anyway, the stock JSON.net doesn't work in Unity. Even though it's a C# library. So there are a number of different projects which have sort of like essentially ported it to work within Unity. One such project is the one I'm using right now. Just on GitHub, there's this open source JSON.net for Unity. So we're going to use this. You'll notice under the install directions, there are a number of different options that it lists for how you would install it. Probably the best option is this one here, installation via UPM. UPM stands for Unity Package Manager. Doing it this way involves a bit of manipulation of a text file directly, which is fine.